Water, something we associate with life, isn't just found on Earth. Around Jupiter, scientists have discovered strong indications of water in places we never expected. Welcome back to Infinity Beyond. In this segment, we take a close look at Jupiter's moons and what infrared images tell us about the presence of water and ice, hidden just beneath their surfaces. One of the highest resolution infrared images ever captured of a Jovian body shows an incredible level of detail. This image spans only about 200 kilometers, but what it reveals is profound. In this small area, concentrated water is found within an impact crater. Yet curiously, there is a ring immediately surrounding the crater where no water is detected. Then again, water appears further out in what scientists call a ray system, patterns extending like spokes from the center of the impact site. Why this pattern? It turns out the water isn't just sitting on the surface. The impactor, a comet or asteroid, struck hard enough to punch through the dry upper crust and expose the icy subsurf. When this happened, the central region filled with exposed water ice, while the immediate ring was likely superheated and momentarily vaporized. The further-reaching rays represent splashed-out material that settled back onto the surface, bringing icy fragments with it. This kind of pattern tells us a lot. It confirms that many of Jupiter's moons, particularly Europa, Ganymede, and even Callisto, have subsurface ice layers. Some may even contain subsurface oceans, sealed beneath thick, icy shells. Infrared images, capable of penetrating the upper layers of surface regolith, help us detect temperature differences and map ice distribution with surprising accuracy. Europa, in particular, is considered one of the best candidates for hosting alien life. Its surface is crisscrossed with reddish lines, thought to be fractures where water from below has welled up and frozen. Spectroscopy from both Earth-based telescopes and spacecraft indicates not just water ice, but possibly salts and organic compounds as well, ingredients necessary for life as we know it. The presence of water also plays into Jupiter's larger ecosystem. Remember, Jupiter's magnetic field is the most powerful in the solar system. These moons orbit within that magnetic bubble, known as the magnetosphere. As water vapor and particles escape from the icy surfaces, especially from volcanic moons like Io or subsurface plumes on Europa, they get caught in the magnetosphere, fueling radiation belts and auroras. These escaping particles create a dynamic interaction between Jupiter and its moons, leading to energy exchanges that light up the planet's poles with auroral rings. In fact, these auroras are far more intense and constant than Earth's northern lights, and they're fed by this very system of water, ice, and plasma exchange. Future missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are equipped with advanced instruments that will further probe this system. Their radars and infrared sensors will allow scientists to see beneath the surface, confirming the presence, depth, and composition of these ice layers. If a subsurface ocean is confirmed, it may open one of the greatest chapters in planetary science. Could life exist beneath that frozen shell? Maybe not surface-dwelling creatures, but microscopic life, adapted to dark, salty environments warmed by tidal heating, remains a very real possibility. The concept is similar to Earth's deep oceanic hydrothermal vents, where ecosystems thrive without sunlight. Infrared technology continues to redefine what we know about Jupiter's system. It gives us not only visual evidence of water, but also thermal clues to subsurface structure, impact dynamics, and even past geological activity. It's like having X-ray vision over a planetary scale. As we wrap up this section of our journey, it becomes clear Jupiter isn't alone in its grandeur. Its moons hold secrets that may be even more profound. Stay with Infinity Beyond as we next turn to explore the mighty magnetosphere of Jupiter, an invisible force field larger than the Sun itself.